go by convention. And if you do that, you can find you very interesting. Otherwise, it's one of the subject which people are aversion of. So you can make the students like microwaves or create interest if you follow this method. Maybe after this hours can tell the opinion afterwards. Uh, in all my lecture, there won't be any E cross and divergence curve E gets lecture. Definitely people like network theory comparatively feel like it. So you remember to feel like the form of network theory is not like you have seen in many of the books, all the standard books, the D pi equivalent of a transmission line. It's just a D pi network, but the inside variables are Z naught gamma L, the transmission line representation. So in fact, in the network theory, we talk about maximum power transfer theorem. In microwave, we do not call maximum power transfer theorem. We say reflection coefficient is 0 or 1, Q is 1. So that way, you just find the analogy. It's not very like a microwave theory, network theory. Then microwave is just very simple. In fact, people say there is no law like Kirchhoff's voltage law or Kirchhoff's current law. The extreme case of the maximum equation is KVL is. So that way, if you find out the analogy, then you can find out you can take the students' interest towards the microwaves. These are the various, everything is on lambda output. Even the mental, everybody works on lambda. If I give you then get what is on. If you ask me, I can easily find it. It's all by resonance only. Resonance is able to lambda. The whole thing, classification, whatever is based on wavelength. So that way, this is the whole spectrum on the wavelength. And we have got many regions in this hall itself. And I consider it's not I consider the whole world consider this lady as the living legend of millimeter wave. You know about J.C. Bose. People say it's a misnomer that Marconi is not the father of radio, it is J.C. Bose. But as far as the living legend of millimeter wave is concerned, is what the but her three-line book is the Bible. This is our FIC world. Whatever components here, nothing like whether it is California, Chandigarh, the components are same, the size may be different depending upon the sizes. So these are the maximum components that if you integrate and make it in form of a system. And if you want to design, you don't need any of the software, any of the big equation. One equation is sufficient. You can keep developing it. It's all based on integer multiple of lambda g by 4 or lambda g by 8 or lambda g by 16. So these are the whole thing. And another thing, we have got so many, these are the 5 planar transmission line, almost missing, Bitang is missing. So those are the 5 planar, all other things are variants of that. Why I am pointing out that is, if you are good in design of any one planar transmission lines, the design in another planar transmission line will not be different, because everywhere we replace by lambda g. So lambda g is equal to lambda naught by root of epsilon effective. You whichever transmission line you want, that epsilon effective you replace it. So that's how, if you know in terms of lambda g, it is design is not different from maybe the layout may be different, but design methodology will not be different. And this also, as far as the students are concerned, one should not mug up what are the individual properties. You should know to which mode each belongs. Then you can easily tell what are its properties. But only thing is you should know the properties of that mode. Like the first one is a pure TM mode, next is quasi TM mode, not TM mode. So like that, the hybrid mode is for twin line. That way you categorize it. And this is another thing. If you don't know about this, only thing is if you know what is the origin of the naming, then you will not forget even the people say K band, 2 band, 4 band, but if you know what's the reason of that, K in German is small, under K is KU, after K is KA. So likewise short, long, then cross, something should be compromised C. That's how these bands have come. That is purely depends upon the wavelength. And this peacock I'm just showing not because of the national bird, and we are seeing these different colors only because of the various wavelength, nanotechnology. Each color we are able to see because of the wavelength. And even though I will not talk about E and H, one should not forget Maxwell's equations. So you just print it on the coffee cup. Whenever you get, you just remember it. And so that is not needed. This equation is sufficient. You just name any of the design can easily be done by this equation. Definitely microwaves, whether it's difference or many things made of silver and gold. So the gamma definitely will become alpha plus j beta. Once you make alpha 0, this will become trigonometric. That equation is sufficient. You tell anything that can be designed from this equation. So the max equations are not required. Maybe for the analysis you need. For the design purpose, this is sufficient. This equation will be enough for all the design. Because this is what people know. You derive voltage equation, current equation, divide it, then get the sending and impedance. The first thing you get is, first of all, you make this trigonometry. Even from here, you get ABCD parameters because the static parameters of the light blend of the network. At least students can note out the application note 154. That will be the Bible for S parameters. So now you can keep getting the various values. If you want to get ZSC, then you get JZ not tan beta. If you get ZOC, you get Z not by J tan beta. All those things will work. Whatever we say, it is from 0 to lambda g by 4. Definitely other lambda g also it will work, but in the opposite way. So now this is the popular one. Many of the good books. The best book I can recommend is Transmission Lines by Johnson. That's a classical book. So many of the books this you can see and cover. Many may not know what is the implication of this. There are only two elements in the whole world, inductor and a capacitor. And if you know how to design inductor capacitor, you can have a combination, get resonance. In fact, resonance circuit is the equivalent circuit for the antenna. So that way, if you make ZSC, you get JZ not tan beta. So depending upon the lambda, you can find out whatever is the, or if you give the values of the inductor and capacitor, the length of the transmission line will give that inductor and that capacitor. Or you can even realize the same thing by ZOC. It will be in the opposite of that. So this is purely in terms of lambda versus impedance. The next one, one application you can see about the lambda by 2. Actual application of lambda by 2 is in the maximum power transfer theorem when you want to equate complex impedance to real impedance, 3 plus J4 to 5. Then you need, you say ZS modulus equal to ZL modulus. So that if you want to do it in microwaves, you take a lambda by 8 transmission line, then join. The purpose of using lambda by 8 here is, if you put lambda by 8, then tan 45 will become as 1. So you get as one is as ZS, the other as 1 by CS. So that becomes a capacitance. Only thing is the difference from low frequency and high frequency is whatever you get the G parameters directly is the inductance value, whereas the reciprocal is the capacitance value. So this is the lambda G by 8. And again here, these are the only two methods by which you can realize the LNC. One is the stub method, the other is the low impedance, high impedance method. So this also, as far as thumb rule is concerned, the second one will has to be remembered for designing inductor. The first one has to be remembered for capacitor. That will work between 0 to lambda g by 4. The other way, lambda g by 4 to the one, it will act in the opposite way. So the main element is the central one, the side one are the end inductance and end capacitance, which you don't require. So you don't need to remember all those formulas. Remember this equation, this T and pi network, T and pi equivalent of a transmission line. It's a very powerful sentence. T and pi equivalent of infinite finite length of a transmission line. So that way, this is another method of getting LNC. And people say, we have seen so many papers, they have seen where to give the feed. So what they do is they take the software, keep on trying various positions. Wherever you get the maximum result, then they say that's the point of feeding. Whereas again, we can use it with the transmission line method and find out what is the point where you can get the maximum. So there is no need of sitting for 3-4 days and finding out where is the optimum point. You can directly pinpoint it within some 2-3 minutes. So that way you can simply expand the first equation what you have written for left side, right side. Again, it is in the form of you replace the beta by 2 pi by lambda g. Once you put lambda g, it will take care of all the transmission lines. So give various values of L1 in terms of lambda. Then you can get the exact input impedance. And why I showed this directional coupler is, um, there is nothing, no active component, no biasing, nothing. The Wedderhole couplers are separated by lambda g by 4. So that way, if you add the waves coming in fourth port and add in third port, you can see that the port 3, it will get cancelled. E raised to minus j beta l, you multiply by 2 times. So that is different from e raised to minus j to beta l. So we put beta as 2 pi by lambda g by 4. So that way the lambda g by 4 makes power get added in one place, whereas it gets subtracted. That's why you say that the directivity is infinite. So again here lambda g by 4 plays a role. The power divider, whether it is a Wilkinson power divider or Arnett power divider, there are only two methods. The central one can be Z0 by 2, or it can be root 2 Z0. Sometimes you will be getting a higher bit or lower bit. So again, lambda g by 4 plays. So here again, you have got a rat race, or you can have a circular hybrid. If the values of impedance are same, then you will get to the rat race. So here you get 6 times of lambda g by 4. So this length makes everything. If you take a rectangular coordinate, you got 3 dimensions. As far as the h is concerned, you don't need to bother the manufacturer's concern. The other two things are the length and the width. Width depends upon your ABCD parameter and the impedance, which otherwise in terms of static parameter. Whereas what is another, the 60% of the contribution is the overall length. So this, in fact, this is the MIC version of the magic key, and you can add any two ports and say where the power is coming, where the power is not coming. So what is my stress is, what is the importance of lambda by 4? So in the first equation, if you write lambda g by 4, you get Z0 squared is equal to Zs into Zr. So that's why you get it as an inverter. Whereas the other one, if you put lambda by 2, you get it as an inverter. You get it as a repeater, lambda by 2. Whereas if you put lambda by 8, you get the modulus of Zs equal to modulus of Zl. So that's nothing very big equation to be remembered. So again, this lambda makes this one. So that is the magic. In magic T, there is nothing magic. When you give T10 in one port, automatically the last one, the fourth port will get isolated. Equal power will come to the third and fourth, which is lambda. So again here, what we see, the first one is the MIC version of the directional coupler. Again, each Shantom series sum is lambda g by 4, whereas the other one is the whole length is circumferential length is 6 times of lambda g by 4. So whatever component I show, it all will be in the multiple of lambda g by 4. You can have 7 by 2. So different kinds of lambda is that. That only makes everything work in the respective manner. And as far as this is concerned, people know the basic difference between stub method and low impedance, high impedance method. So here again, you have to take care of the sine inverse of omega l. Again, that is in terms of lambda. Whereas the other one, each section is lambda g by 4, coupled section. Then, as a single full thing, if you take, it will be lambda g by 2. So that way, here also. Then here, one of the feet. Which is the length is lambda g by 4. That is because of it is matching the 50 ohms to the antenna impedance. So here again, the feed section you can easily find out the length by that method. And if you take the guitar string, it is not only the microwave, everywhere. You have the first 3 natural frequencies of the guitar. Again, it is lambda by 2, 3 lambda by 2. And here, the resonator. There are two types. You can have the two feed lines or a single feed line. In one case, 2 pi r will be equal to pi n. Other case, it will be pi n by 2, pi n lambda by 2. And if you can make the microstrip slightly thicker, wider, then this will act as a very good antenna. So that's what all these things. So here again, once you want to have the corporate feed, again every point you should find out what are the impedance. It can equally divided. So you take the impedance, take the square root, and the length, take it as lambda g by 4. And there's nothing like a conventional. The best antenna is with epsilon naught equal to 1. And definitely you cannot assume this kind of antenna keeping on the satellite. So you have to forego certain advantages, and that's why you go for miniaturization. So this is again a parabolic dish you can design only if you know in terms of the lambda. Certain applications you cannot use this, especially this one. These are the profiles designed in terms of Lambda exclusively for the implantable antennas. And this is another thing. You don't need 40 lakhs network analyzer for doing small thing. This inverted Smith chart, every point you invert it by lambda g by 4. So you get the normal Smith not superimposed by the opposite. Z and Y superimposed. After time you can work with series of pattern. And this is the thumb rule. You go by clockwise and anti-clockwise. In the conventional one, you get Z and Y. Whereas if you go in the inverted one, you get susceptance value of inductance and the capacitance. So this, if you remember, you can easily do the design the amplifiers without referring anything. So again, this is in terms of different lambda. This is what you get. You don't need to know where is to be the field point is difficult. You just make use of transcription line, find out the real part and imaginary part. The imaginary part you cancel it, real part you take and take the reciprocal of it. And that resistance and the antenna resistance you take the square root, and that will be the impedance of the connecting line. And the length of that is lambda g by 4. So here you can see 0.16. Then as far as the patch antenna is concerned, if the A dimension is more than B, then you get TM10. If it is less than B, it is TM01. If you make both A and B, it is not that only one side it will be radiating. If you make A is equal to B, then the rectangular patch will become a square. And under this condition, TM10, TM01, both will become have the same effect. And all the four sides it will be radiating. And you can view the field at the center point. So that's why you get lambda by 4 by lambda by 4. So this is what we have seen last 2 days before. When you are talking about active integrate antenna, when you take shaped angular ring, you get 0.041 lambda g squared at f6. So this is apart from other standard wavelengths. So the 0.265, 0.272. Likewise, that's a very interesting phenomenon about 5 by 32 lambda g. People say there is no isotropic antenna existing physically. But if you take a small paper clip and have a circular loop with 5 by 32 and keep it in the air, the radiation will be similar to the isotropic antenna. So likewise, it is not the standard lengths lambda. There are many more things. You can come up with. As far as this is concerned, we have seen that when you keep the SRR below the antenna and use it for biological effect, the SAR can be reduced. So that is again in terms of lambda. This is a small example for biomics. So biomics, RFMs, everything works on the micro principle only. Only thing is the fabrication method is different. Again, it is all in the multiple of integer multiple of lambda g by 4. And again, we got these are the maximum connectors for microwaves. And here, some of the connectors, the diameter length is in terms of lambda g by 4. This I am showing for two purposes. One, everything we got from nature. The fractal antenna, most of the dimension was got from the nature. And these kind of tree or ferns, from there only they got the geometry. And when you use the software, they keep on iterate. Whereas if you use in terms of lambda g by 4 into the integer multiple, you also can self-design. So that is the one reason. The second reason is these days we don't see these sparrows mainly because of the biological effect of microwave. Now, this tool has beaten the Moore's law. Richard Feynman at one time told about this sentence. That's how this was the inspiring sentence for the my MIMS. And again, this is the MIMS antenna. The MIMS antenna, RF MIMS antenna is nothing different from the other dimension, other design factors. It is same as what we do in microwaves. Only thing is the air is introduced. It's what this is reading is, and method of fabrication is different. But all other things has got same lambda g by 2. Only thing we say centimeters in microwaves or millimeters. Whereas once you go to these branches, we call in terms of micrometer. The applicator also, this has got effective heating only if it has got some integer multiples of lambda equal to 4. So these are the different things. Lambda by 8, no, 5 lambda by 16, 5 lambda by 14. So people can, the same, that equation can be taken and then keep putting different values, you will get interesting results for different applications. And these are the, see, normally we say what is electrically small. Now, whenever you design, we say it is between 0 to lambda. Electrically small means around 0.1 lambda, so 1 by 10 lambda now. So that way, different values of lambda have got different applications. So these people are aware of it, but as you vary the lambda, the radiation pattern shapes are known. And here, when you operate it at lambda by 8, then you have the application for W2A. This is when you take the short divisor, if the distance is in terms of 7 by 32 lambda, then you get the maximum. That means the slot element, we make it as 5 lambda by 14. Then you get the very good response. So you know very well periodic antenna, when you take lambda by 2, the consecutive one will be added by 0.5 times, or the consecutive fringe one is subtracted by 0.5. So we get 0.45, 0.3, so also. So this is how we calculate. It is not simply using everywhere what is the correction factor. You can use it by getting the by doing fluid analysis of the discontinuity effect. Then this is not that it is simply lambda by 2. This is just you should know. Because whenever people design filters, they know low impedance and high impedance. Low impedance of one transmission line will be the high impedance of some other transmission line. So that way this also should be known. And this is what I was telling. You remember everything in terms of lambda g. And if you know, if you want to do it in the strip line, you replace epsilon effective by epsilon r, because this being a homogeneous. Whereas if you want to extend that for the co-plane or maybe a field line, you replace the epsilon effective. So in any case, if you know everything in terms of lambda, the design methodology will not be different for different transmission lines. You should just have an idea of how to find out the epsilon effective. You can use the respective Bible for each transmission line and get all these things. So this again CPU review. In general, it's lambda by 2. Then afterwards, you can make use of the correction factor and things. This is the summary of all the requirements of an antenna. What are the geometry, simulation software, characteristics, how to choose the material, feed mechanism, computation methods, software tools. And this I am showing, just like I showed Peter. From this only, people have got the nano plates, the rotors. From this only they got the techniques of nano plates. So you can find out what is the lambda corresponding to that. So again, you can make the screenshot and find out all the matching, because we are the world matching agents. Again, if you take a splitting resonator, the whole size will become smaller than the resonance frequency. So again, it is in terms of lambda by 2. And you go to metamaterial, then also you can find out the unit cell size. If it is far less than lambda, then you get effective Eugen theory. If it is just equal to approximately equal to lambda, then you get photonic effect. If it is far greater than lambda, then you get your usual effect. So these are the comparison of them. And here you can see one more new figure. You get 74 times of improvement when it is lambda by 1000 size. So this is all the things you know the radiation pattern. Again, we call this popular windows. So this windows also you can tell in terms of lambda. And each color has got different lambda. Then blackboard radiation also in terms of lambda. And once you go to the opposite of the inverted one, you can talk in terms of 1 by 8 and 3 by 8 also. And techniques and the various methods of getting LC series, all combinations you can get it from. And again, biomedical application also, that also you can find out the effect of lambdas, logarithmic variation. Sounds also. Everyone is aware of, as you keep varying the length, lambda by 2, lambda 2, lambda 3, lambda, you can find out what are the effective pattern. This is what we got result. Not by using the software, by writing our own coding for a number of limits using lambda for different lambda. Okay, I simply thought, why not I summarize unsolved, I will give the overview of all the lambdas and then present you. And as I told, it is not the exhaustive one. And few more lambdas. All what I am showing is the SPAN. This is the rank cost filter. So again, one section is lambda by 2, the last section is spiral antenna. Going periods, high periods. Previously, what I showed was each couple this uncoupled one. This is a resonator. Here the image version of that, it is a series of lambda equals 4. You put lambda, you get the angle. If you put the angle, you get the lambda. Especially in the case of rat race, people will say we take it as 6 times. Geometrical angle will come at 20 degrees. Only when you do this kind of number, you will take the direct value as 45 degrees. So that is power divider. Whichever component you take, it's all is a value of like 4. So students will know the exact understanding and you can take the value antenna. Each reflector that has got different standard lambdas. The distance also of different antenna. This is the FAC version of radio antenna. And the last one I want to show. You combine all those components, then you get a single balance mixer. You have a hybrid. Whatever I showed you the square type, then you make it the circular one. Circular one, if you do, you can avoid all those discontinuities, weighted discontinuities. Whereas if you have a circular one, the same thing. Z not by 2, Z not by 2, Z not. So here is the hybrid, then here is the put the transistor, you get the IC, then band pass filter. So that way you combine all those components, make the system, take the regular output and then you get a double balance. In any case, I just want to stress that lambda 3 by 4, multiple of them is not the standard values anyway itself. Many lambdas. Or you can keep finding more application by the values of lambda. Many cases lambda length means little. So always stand for the change.
Thank you, Professor Raghavan, for a illustrative lecture on applicability of lambda for various components, starting from the known level to advanced level of technology. Anybody would like to interact with Professor Raghavan? Thank you, sir. The next lecture will be an invited of new trends in antenna research, PC and dielectric profiles by Professor Raghavan, Institute of Radio and Space Physics, Calcutta. Madam Suman,
Where is the organizers? Because the time is too short. So, what size is ultimately? At what time you will leave? Because the people have to go back, the room, the painting is coming. So let him come. Yeah, Yoshi, please come. Anyway, I don't need any microphone. Actually, you are here for just 5 days. I prepared my talk in the name of my journey and realization, basically for you. Anyway, the time is too short. I am not going to express the thing, but the gist is like this. I'm too young in this field. Like I came to antenna area really by chance. My friends done it. Forget about Professor God and other people. They're too senior. It is very embarrassing for me to say something about this thing. That's why I changed the title. Just my experience. Actually, I've been working in this field for the last 15 years. And in 15 years, I had to change my field 3 times. So that's why, without changing your focus, you won't survive in this field. Be very careful. Please don't try to squeeze the same thing repeatedly just by cutting slot or changing marginal thing. By this way, there are 2 effects. One, you won't be satisfied at the end of the day. I'm not telling you about the end of the life, but actually I mean that. You'll be frustrated. Second one, when you'll be going abroad and you'll present your paper, the whole international community will laugh. That 1, 4, and 5, all are basically very old and absolutely saturated field. But you face one problem compared to the people in advanced country or US, that neither you nor your supervisor get any feedback from industry. That's why you have to find your own problem. Normally the US professors, US researchers, they get direct feedback or direct query from the industry that we want this, you have to do this. That is the challenge. If you don't meet this challenge, then it's irrelevant to do any research in any field, particularly in technology. I don't consider myself a scientist. I'm basically antenna engineer. Antenna radiation, that is the problem of antenna. In most of the cases, you are very, very much concerned about your input impedance, but not the radiation. I'm surprised to see many papers you considered feeding the antenna. You're getting the S11, but you are not considering the radiation part. Please don't do this. Try to understand antenna, and understanding is not a very difficult thing. You just go through the state-of-the-art techniques. That's why I thought to address few important issues which are basically open book for you, and you could address it. Please do one thing. If you know my name, just go to Google, search it, and please visit my website. From my website, the front page, you will find I have very recently put it one very recent review talk, and I had to prepare this talk. I should not say this word request, rather it is the order from Professor Rajmitra. Oh, sorry, I can't do this. So that talk is prepared very carefully for the whole international community. So if you are interested to learn about the new things that is open to you for at least next 10 years to work with on microstrip antenna particularly, please do visit and try to understand what's going on new. I have tried few copies for you. So those who are in, particularly in microstrip antenna area, just try to collect it from here. It's only 4 or 5 copies because each one is for 30 or 50 pages. No, Rajiv is the editor in chief.
Yeah. We have also one. So that has been submitted.
So please do it.
That has been submitted.
So please try to understand the physics. And is there any time to go it? 5 minutes? Professor Patnaik? Better to leave now.
Yes, we have finished.
I think I'm done. Okay, sorry, I could not address in detail. So later on, maybe in the future. Thank you very much.
Thank you, Professor. So now my session actually I have dropped. As you know, I have answered so many people. So there was a demand that at least for 10 minutes this week because my talk is not 10 minutes long. If you want that biological interaction, it really needs a lot of detailed discussion. And I am happy that Japit could take care of that. The Japit presentation was more or less like a good background of that. So my experience has taken care of that. But the detail, the research aspect of that, maybe in another forum sometimes. I think we are running still time. So only the one session is wrong. The rest of the things were taken care very nicely. And we go to the candy. Because as you know, the federation session is arranged outside the hall, bring a change to you. And it is not that hot region, it is totally cool. They have put 60 acids there. So it is going to be a different experience for you. So we do our prediction in that place, 1 hour prediction, and 12 o'clock we give you an idea and we go on the rest of your place. So that is the way we have to go out. Go this way, go out of the this quarter, then right on. That not we are waiting.